Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky.
Stéphane Guizard loves the stars. No wonder he loves northern Chile too. Here, the view of the universe is amongst the best in the world. And no wonder he loves the European Southern Observatory, Europe's eye on the sky. Stéphane is a prize-winning French photographer and author. He is also one of ESO's photo ambassadors. In breathtaking pictures, he captures the solitude of the Atacama Desert, the high-tech perfection of giant telescopes, and the magnificence of the night sky. Like his fellow photo ambassadors from all over the world, Stéphane helps in spreading ESO's message. A message of curiosity, wonder, and inspiration, proclaimed through cooperation and outreach.
Cooperation has always been the basis of ESO's success. 50 years ago, the European Southern Observatory started out with 5 founding member states: Belgium, France, Germany, the Netherlands and Sweden. Soon, other European countries followed: Denmark in 1967, Italy and Switzerland in 1982, Portugal in 2001, and the United Kingdom in 2002. Over the past decade, Finland, Spain, the Czech Republic and Austria also joined Europe's largest astronomy organization. Most recently, Brazil became ESO's 15th member state and the first non-European country to join. Who knows? The member states enable the best possible astronomical science at the world's largest observatories.
It's good for their economies too. ESO closely cooperates with industry in both Europe and Chile. Access roads had to be constructed. Mountaintops had to be leveled. The Italian industrial consortium AES built the main structure of the 4 VLT telescopes. Each telescope weighs in at some 430 tons. They also constructed the giant enclosures, each as high as a 10-story building. The German glass company Schott produced the delicate VLT mirrors, over 8 meters wide and just 20 centimeters thick. At Riosque in France, the mirrors were polished to a precision of a millionth of a millimeter before they made the long journey to Paranal. Meanwhile, universities and research institutes across Europe developed sensitive cameras and spectrometers.
ESO's telescopes are built with taxpayers' money, your money, and so you can take part in the excitement.
For example, ESO's website is a rich source of astronomical information, including thousands of beautiful pictures and videos. Also, ESO produces magazines, press releases and video documentaries, such as the one you're watching right now. And throughout the world, the European Southern Observatory contributes to exhibitions and science fairs. Countless ways to participate in the discovery of the cosmos.
Did you know that the names of the 4 VLT telescopes were thought up by a young Chilean girl? 17-year-old José Albanés Castilla suggested the names Antu, Cuyen, Melipal and Yepun, meaning sun, moon, Southern Cross and Venus in the Mapuche language.
Involving school children and students like Horsey is important. That's where ESO's educational activities come in, like student exercises and school lectures. When the planet Venus passed in front of the Sun in 2004, a special program was aimed at European students and teachers. And in 2009, during the International Year of Astronomy, ESO reached millions of school children and students all over the world. After all, today's children are tomorrow's astronomers. But in terms of outreach, nothing beats the universe itself. Astronomy is a visual science. Images of galaxies, star clusters, and stellar nurseries fire our imagination. When not doing science, ESO's telescopes are sometimes used for the Cosmic Gems program, taking pictures just for the purpose of education and public outreach. After all, a picture is worth 1,000 words. The general public can even take part in creating these staggering images through the Hidden Treasures competitions. Russian astronomy enthusiast Igor Chekalin won the competition in 2010. His marvelous images are based on real science data.
Member states, industry and universities. By cooperating on all possible levels, ESO has become one of the most successful astronomy organizations in the world. And through its engagement with the public, you are invited to join the adventure. The universe is yours to discover. Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky.
For half a century, the European Southern Observatory has showcased the splendor of the universe. Starlight rains down on the Earth. Giant telescopes catch the cosmic photons and feed them to state-of-the-art cameras and spectrographs. Today's astronomical images are very different from those of the 1960s. When ESO began back in 1962, astronomers used large photographic glass plates. Not very sensitive, imprecise, and hard to handle. What a difference today's electronic detectors have made. They catch almost every photon. The images are available instantaneously, and, most importantly, they can be processed and analysed by computer software. Astronomy has truly become a digital science.
ESO telescopes use some of the largest and most sensitive detectors in the world. The Vista camera has no less than 16 of them, for a total of 67 million pixels.
This huge instrument catches infrared light from cosmic dust clouds, newborn stars, and distant galaxies. Liquid helium keeps the detectors at -269 degrees. Vista takes an inventory of the southern sky, like an explorer surveying an unknown continent.
The VLT survey telescope is another discovery machine, but this one works at visible wavelengths.
Its camera, called OmegaCam, is even larger. 32 CCDs team up to produce spectacular images with a mind-boggling 268 million pixels. The field of view is 1 square degree, 4 times as large as the full moon. OmegaCam generates 50 gigabytes of data every night. And these are just gorgeous gigabytes.
Survey telescopes like VISTA and the VST also mine the sky for rare and interesting objects. Astronomers then use the sheer power of the VLT to study these objects in exquisite detail. Each of the VLT's 4 telescopes has its own set of unique instruments, each with its own particular strengths. Without these instruments, ESO's giant eye on the sky would be...
They have fanciful names like Isaac, Flames, Hawkeye and Symphony. Giant high-tech machines, each the size of a small car. Their purpose? To record the cosmic photons and recover every possible bit of information.
All of the instruments are unique, but some are a little more special than others. For example, Mako here and Symphony use the VLT's adaptive optics system.
Lasers produce artificial stars that help astronomers to correct for atmospheric blurring. NACO's images are as sharp as if they were taken from outer space. And then there's MIDI and AMBER, 2 interferometric instruments. Here, light waves from 2 or more telescopes are brought together as if they were captured by one giant single mirror. The result? The sharpest views you can imagine. Spectroscopy is one of astronomy's most powerful tools. No wonder ESO boasts some of the world's most advanced spectrographs, like the powerful X-shooter. Images carry more beauty, but spectra reveal more information. Composition, motions, ages. The atmospheres of exoplanets orbiting distant stars. Or newborn galaxies at the edge of the observable universe.
Without spectroscopy, we would just be explorers staring at a beautiful landscape. With spectroscopy, we learn about the landscape's topography, geology, evolution, and composition.
And there's one more thing. Despite its serene beauty, the universe is a violent place. Things go bump in the night, and astronomers want to catch each and every event. Massive stars end their lives in titanic supernova explosions. Some cosmic detonations are so powerful that they briefly outshine their parent galaxy, flooding intergalactic space with invisible high-energy gamma rays. Small robotic telescopes respond to automatic alerts from satellites. Within seconds, they swing into position to study the aftermaths of these explosions. Other roboscopes focus on less dramatic events, such as distant planets that pass in front of their mother stars. The cosmos is in a constant state of flux. ESO tries not to miss a single heartbeat. Cosmology is the study of the universe as a whole, its structure, evolution, and origin. Here, catching as much light as possible is of the essence. These galaxies are so far away that only a handful of photons reach the Earth. But these photons hold clues to the cosmic past. They have travelled for billions of years. They paint a picture of the early days of the universe. That's why big telescopes and sensitive detectors are so important. Over the past 50 years, ESO telescopes have revealed some of the most distant galaxies and quasars ever observed. They even helped to uncover the distribution of dark matter, the nature of which is still a mystery. Who knows what the next 50 years will bring?